This is my pass off for Lab 6, which is trying to make a sensor mesh network connect to a network, um, like a traditional network, like a LAN in a home or something like this. And for this, I use one ESP32S2 that is connected to a DHT22 and another ESP that's just hanging out here. That will be the root node. And so I have several serial tabs open right here. The first one is actually my root node. And the reason I can tell that it's my root node is because it's receiving broadcast messages from my child node. And these broadcast messages are the temperature and the humidity that's being read from the DHT22 sensor. And this updates as often as it can. There's not really a lot to see here. I'm just going to hold it here and wait for another value to update. Like watching paint dry. I believe I'm actually seeing several of them update. It's just, yeah, you can tell it's updated. Okay, cool. And now I will go to this other serial monitor tab, and this is the child node. And the child node is receiving a message from the root node, just a broadcast, a ping from the root node continuously. And in this other tab right here, I have netcat going on, and netcat is just a way for my computer to tell whether or not my root node is actually connected to my home network. So my home network just has port 8083 open and is continuously listening for connections. That's why I have the -K flag. So it won't close the connection. And you can see that every time, as you can tell, this has been going for a while, but every time my root node sends a ping to keep the connection alive, it'll show up in this netcat connection right here. And so I deviated from the lab a little bit and didn't do a traditional TCP server that was hosted here in netcat, but rather I have a web server that is hosted on the root node, and it's an HTTP server. And what this will do is when I type in, and so you can tell first and foremost that the IP address of this guy is 192.168, and the mesh network IP addresses start in my instance with 10.68 or something like that. And so this is how I know. Actually, I'll just go ahead and show you over here by opening up a new tab. If I type in IP space A, oof, sorry, that went out of focus real quick. There we go. You can see that my IP address is 192.168.8644. And so that's how you know, like, this is all on the same subnet, and that the root node is visible in my LAN. But also you can tell because of these tabs here that the mesh is sending, the mesh nodes are sending traffic to each other. And just to prove that my LAN or a device on the LAN can interact with this mesh node, I'll go ahead and I'll type in a message like hello to broadcast. And I think as soon as I hit submit, you can tell right here that actually the child node received the message hello. And the reason that that didn't show up on the root node at all is because this is in fact the root node that is sending that message. So this is hopefully good enough for proof that I was able to set up a mesh network. I used the painless mesh library instead of using the ESP IDF because I couldn't get the MDF module to load and run CMake tasks correctly. And so I kind of had to pivot and get the same functionality done with something else. But that's about it.